Hello and welcome to our showcase solution for Power BI. My name is Bailey Scott and I work as a cloud solutions architect for Cobweb Solutions. Now, we were presented with an issue from one of our customers around an off-grid system that they had. So this first page just gives you an overview of their solution so we understand what measurements we have to take. So the off-grid solution has a system that takes in power either from a generator or from solar panels or from both, and it converts all that power and it can store it in some batteries or it can provide it straight to the house or a bit of both. Now, when we engaged with the customer, we sat down to understand what the problem was with the existing solution. Now, he identified that the system gives him um, a view of what power is available. As you can see from this slide, this is the app that he has on his mobile phone, and it shows how much power he's getting in from his solar panels, how much power he's consuming, and how much voltage is in the batteries and the state of charge. It also shows the power coming from the generator if the generator is being used. Now, the problem that he has is that this window that you can see on the screen is only updated every 5 minutes, and that wasn't suitable for him. He wanted a more real-time view of his power. Now, the customer did admit that there is a kind of partial solution, which you can now see on the screen, which is when he connects to the remote console of the system. And you can see in real time the AC load, which is the power being consumed by the house, the power coming in from the solar panels. Now, top left, the AC input. If the generator is switched on, you would see the power coming in there. You can also see the batteries on the bottom left, 48% charged and 54.8 volts. So, and you can see this is ticking over in real time, but the issue with this is that only one user can access this at a time. If another user connects, it disconnects the previous user. So, multiple members of his household need to be able to see the stats in real time. So, whilst there is a partial solution there, it wasn't sufficient to meet his requirements. So we kind of analysed the solution and really kind of thought about how we best do this. So the off-grid system actually was a Linux derivative, and we were perfectly able to add a script that would post data to an API. So we set up an event hub in Azure, and we configured the system to post its data to the URL of the API for the Event Hub. We then took the output from the Event Hub and passed it into Stream Analytics. And Stream Analytics then passed it to two places, the data to two places in real time. The first place being the actual Power BI streaming data set and also a SQL database. And this SQL database would store the same data that you would be seeing in your streaming data set, but it would allow us to historically analyze the system and how it was performing. So we basically came up with two parts of the solution here. The first part being a standard Power BI data set and dashboard from a SQL database that would allow us to kind of historically analyze how well the system was performing and other statistics. The second part, and the more important part to the customer, was the real-time data set, which was taken straight from Stream Analytics and plugged directly into Power BI in order to give us a real-time Power BI dashboard. And we will now demonstrate both parts of the solution to you. And now what we can see on the screen is the first part of our solution, the real-time dashboards. Now, I'll be the first to admit that the visuals available to real-time dashboards aren't the most aesthetically pleasing. There are very few visuals to choose from as well. But what we've done is we have four measures: solar power, battery, power consumption, and state of charge. And what we've presented are four line graphs in order to give us a kind of historic view over the last hour, and also four cards that will give us the latest measurement of each of the components, so the solar power, battery, power consumption, and state of charge. And as you can see, it's ticking through quite nicely. Now, the second part of our solution is a standard dashboard that gives us some historic analysis, but not real time. So it obviously looks a lot prettier because the number of visuals that you have available is greater. Now, if we look at the left-hand side of the screen here of the dashboard, you'll see the power consumption today. The maximum was around 3,754 watts, and that was around 1:30 in the afternoon. But the average was only around 355 watts. The solar power, we had a maximum of 3,517 watts coming in, and that was around 11:30 in the morning. And that kind of ties in roughly with when the sun's at its highest. So that kind of makes sense. The average solar power coming in was only 441 watts. But keep in mind that during the night, if we excluded the nighttime hours, the average of the solar power would be higher. The next graph at the top in the center is a line graph with two measurements, solar power and power consumed. And this shows a previous week. So the yellow is the solar power, and you can see it obviously peaks around midday and then starts dropping off again. And then during the night, there's no solar power coming in at all. The power consumed kind of follows a rough same pattern that, when people are up during the day, their power consumption increases, and during the night, it's slightly less. The donut on the top right, there are two rings to the donut. The central ring, which shows the power coming in. Now that can be from the generator or from solar power. Today, the generator was not switched on, so our entire power came from the solar panels, and it's approximately 11 kilowatt hours we managed to gather. Now this is broken up on the outer ring into two sections, the power consumed and the power stored. And you can see the red section of the outside ring of the donut. We've used consumed directly around 9 kilowatt hours, and going to the battery, we've stored around 2 kilowatt hours, and that goes to storage in the battery. The combination chart on the bottom is intended to give you an analysis of the power used and the power consumed, the power stored, the generated power, and the solar power. Now these are formed into stacks. So the first stack is the power out, if you like. So the power consumed is the red, the power stored is the blue. The next stack is the generated power, if there has been any, and the solar power, and that forms the power in, and they should really match up. So if we look at May, for example, we've got 151 kilowatt hours being consumed and roughly 48 kilowatt hours being stored in the battery. And the total of that is effectively the solar power that's come in because there was no generator used in May. The third column in the stack is a representation of how much solar power is potentially available, and this is based on sunrise and sunset times. So it just gives you an idea of what's actually available in terms of solar. Again, if it's a cloudy day, then there will be less solar power coming in, and therefore less stored in the batteries. So we'd never really quite reach the maximum solar power available because cloud cover, etc. And really, that is the kind of analysis that we've done in this dashboard to give some historic analysis of the power situation on this off-grid home. So we're more or less finished demonstrating our Power BI Showcase solution. Um, we tried not to go with the normal finance reports, just to give you an idea of something else that can be done with Power BI. But of course, we do regularly do financial reporting within Power BI. If you've enjoyed what you've watched today, or you need help with Power BI or anything in the Power Platform solution, please do reach out to us. You can reach us at the email address and website on the screen now. Again, thank you very much for watching. Thanks.